Mobilemaths with Gamchirai. Today I want to look at series. So on this video, I'm going to look at an introduction to series. Okay, so what we are going to look at today, we want to look at series. Previous lessons we've been looking at sequences. Okay, now we have introduced a new term, series. When we look at sequences and series, these two are basically similar. The difference is that in series, or when we talk about series, the terms that we have in a series, they will be added together. I can have an example here where I have a sequence which has got some commas, this one. Then when we have a series now, we are introducing addition sign. So we'll have 1 plus 3, 3 plus 5, and so on. Okay, so this becomes a series. Okay, we have what we also call notations when we talk of series. I can have an SN notation where on this SN, the S simply refer to sum or summation of terms, and the N refers to the number of terms. Okay, so an example here, I have got S2, where when we have S2, summation of two terms, it means we can simply say is the sum of T1 and T2. I'll further explain this later on using an example. Okay, so example number 1 that I have here is this one. We have got S1. So this is summation of one term. S1 is summation of one term or first term. So using the previous series that we had, which was 1 plus 3 plus 5 plus 7 plus 9. Okay, what it means on this series is that this one here can be written or is termed T1. 3 there is term number 2. 5 is term number 3. 7 is T4, term number 4. And 9 is T5. That's what basically this means. Now, going back to our S1. S1 is equal to summation of first term. Okay, so because it's 1, we will have our summation of one term being equal to 1. The same, this one, that's the one that we are referring to. Okay, let's have another example. Now I've got summation of two terms. Okay, so it means I'm going to add the first two terms in the series. Using the same series, I have 1 plus 3 plus 5 plus 7 plus 9 and so on. Okay, and remember we said 1 is our T1, 3 is our T2. So when we talk of S2, it means we are adding term number 1 plus term number 2. Okay, and when we look at those term number 1 and term number 2, this is our term number 1, so I can have is equal to 1 plus our term number 2 is 3, so plus 3. So S2 becomes equal to 4. So this is the result of summation of terms of two terms. Okay, so even if you want to look at summation of 3 terms, it means you simply go on and on like that. Let's have a look at arithmetic series. Okay, so remember we said this is sum of n terms. So when we look at an arithmetic series, we can have a formula, or I can go on and have, let's have our series. We had our series as 1 plus 3 plus 5 plus 7 plus 9 plus ... Okay, up to nth term. Then So here I'm just trying to write this in this, matching these terms explain here. Okay, now with those terms we can derive a formula. We can derive a formula for arithmetic series when we know the last term of our series. So if we know the value of this term, let's say it's 110, okay, we can use a formula. We will have a lesson whereby we'll derive these formulas later on. We can use a formula Sn summation of n terms is equal to n over 2 bracket a plus l. The l here basically is the last term that I'm saying it's known there. That is 110 in my case, that I'm just trying to elaborate the terms there. Okay, so that will be the formula that we use. Then when we don't know the last term, what we do is this. We can find L and replace it. So when we do that, we'll come up and have this formula. Okay, so we'll also generate this one later on in another video. So this is when we have the last term is not known. So we have got this one. Okay, that's the equation that we have. It's only differing here where we have got 2a plus n minus 1d there. Okay, now that we have got that, let's look at geometric series. For geometric series, we have got also two different formulas. The first formula is being controlled, or is being governed by this, is being governed by R. When our R, which is our ratio, common ratio, is greater than 1, we'll use this formula such that when it's greater than 1, let's say our R is equal to 2. So when we have 2 minus 1, we'll have a value here. We can have over 1 there. A R to the power of n minus 1. Okay. Even when its R is equal to 3, we can have now the denominator here changes and becomes 2 here. Okay, so it is valid. Our equation will be valid. But when we have our R less than, then the formula changes. Okay, so when we have our R greater than, less than 1, then the formula now changes. We interchange the denominator and also the numerator here. We now say 1 minus R, since our R is small. Let's say our R is equal to 0.5. It means we can have a value here. We'll have 1 minus 0.5. Okay, and it will be valid. That's basically what we'll be trying to do. Maybe now, for you to understand, let's have some examples. I've got a couple of questions that I want us to look at. So the first question that I have, we want to evaluate the sum of each of the following terms. So I've got 20 plus 17 plus 14 plus up to 50 terms. Okay, so this is what we are going to do. Now let's try to solve those three questions there. So for the first one, what I will do is this. I will write terms. So 20 is my T1, 17 is my T2, 14 is my T3, and so on. Okay, like that. So when I have something like this, I can try to see, is it an arithmetic series or is it a geometrical series? So when we talk of arithmetic series, it means we have got a common difference. When we talk of geometrical series, it means we have got the same common ratio. Okay, so let me see. If I say term number 2 minus term number 1, what do I get? I will get 17 minus 20. Sorry, minus 20. There is just minus here, minus 20. 17 minus 20, I will get minus 3. Let's go on to the next one. I can have T3 minus T2 is equal to what? I've got 14 minus 17. I'm also getting a minus 3 there. Okay, so when this happens, it means I've got a common difference here. I've got a common difference. And when we have a common difference, it's denoted by D. It means it's an arithmetic series. Okay, so when it's an arithmetic series, I will use those formulas that I showed you. So now, between those two, we have one which has got last term known and the other one which has got unknown last term. So I don't know the last term. Do I know the last term in this case? I don't know, because they just told us 500 terms, but they didn't tell us the last term. Okay, so we will use this formula. Sn is equal to n over 2a plus n minus 1 by d, like that one. Okay, and minus 3 there, that's our d. Okay, our a is our first term, which is 20. This one, that's our a. And our n, the number of terms we were told in this case that we have got 500 terms. That's our n there. Okay, so having that information, we can now write and say Sn, we said it's 100, it's 500, so we have got S 500 terms. We want to find the sum of 500 terms is equal to 500 over 2 by 2. Our A, we said, is 20, plus n 500 again, minus 1 by d, common difference, minus 3, like that. Now we can simplify. You can either punch this whole number in the calculator, or you can try to simplify it first before you punch, so that you have correct answers. So for myself, I'll divide 500 by 2 divided by 2, I'll get 250. Then this one, 20 by 2, I'll get 40. Then the next one, I'll have plus 49 by minus 3. Okay, so I'm going step by step. So I'll have 250 by 40. Then I've got minus here, minus 1497. If I multiply 499 by minus 3, okay, now I've got that. So now I can even simplify and get the answer. So my final answer is 500, summation of 500 terms becomes minus 364,250. Okay, so this is the solution for the first term, for the first question. Let's go to the second question. The second question, we have got the first term. So this is my T1, T2, T3, and so on. And we have got n terms there as 80 there. Now we want to see, is it an arithmetic sequence, or it's an arithmetic series, or it's an geometrical series? So we do the same. I'll say T2 minus T1. What do I get? I'll get minus 10 minus 4. What do I get? I'll get a 4. Let's go to the next one. I'll have T3 minus T2. I will get minus 6 minus 10. I will get the answer is again the answer is 4. Okay, so it means we have got a common difference 4 there. So our D is equal to 4, and our n terms is equal to 80, and our A is minus 14. We don't have the last term, so we are going to use the same formula. Sn is equal to n over 2. So it's always important to don't make mistakes. N minus 1 by D. Okay, now I've written the formula. I'm now substituting. Let's substitute the data that we have. We have got S up to 80 is equal to 80 over 2 by 2 by A is our minus 14 plus our N is 80 minus 1 by D, which is our 4. Now we can simplify. Simplifying this one, we'll get 40 minus 28. Then here I've got plus 79 by 4. Okay, so I'll end up having 40 by minus 28 plus 316. Okay, simplifying this, at the end of the day, I'll have summation of 80 terms being equal to 11,520. Okay, so this is my final answer that I have. Let's go on to the last question, our C. Okay, so here again I'll have term number 1, term number 2, term number 3, and so on. And this is our N here. Okay, so with this question, I'll also do the common difference. If I say T2 minus T1, what do I get? I'll have 3 minus 1. I'll get a 2. I say T3 minus T2, what do I get? I've got 9 minus 3. I'll have here a 6. So when this happens here, I don't have a common difference. It means it's not an arithmetic sequence. Okay, so we can cancel that. Now we can go and find the common ratio. Let's find the common ratio. Common ratio for this one is this. We are going to say T2 over T1 is equal to 3 over 1. So here I'll have 3. The second one, I can have T3 over T2. I will have a 9 over 3, and I'll get a 3 again. Okay, so I've got a common ratio R as 3. Okay, the first term of the sequence, I have it as A, as 1 there. So we can now use this becomes, okay, this is a geometrical series. This is a geometrical series. Now, having known that this is a geometrical series, we can now use those formulas. Is our R greater than 1 or less than 1? Our R, we said we've got that R and our 1. Our R in this case, we've got our R as 3. So 3 is greater than 1. So we are going to use the formula that has got R is greater than 1. Which one? Which is Sn is equal to A, R to the power of n minus 1 over R minus 1. That's the one that we are going to use. Now let's substitute what we have, the information that we have. Okay, so we have got S summation of 8 terms is equal to 1. That's our A. R is our 3 to the power of 8, which is our n minus 1. Okay, then over 3 minus 1 like that. Okay, so if you punch into the calculator, you will get the summation of 8 terms as 3,280. Okay, that's what you will get. Okay, now let's have another example. Okay, here I've got this example where we want to determine the sum of the first 1,000 natural numbers of a series. Okay, so for this one, you have to write, it is easy for you to write the terms first. So for the series, I can come up with 1 plus 2 plus 3 plus 4 and so on, up to, they said 1,000 here, so up to 1,000. Okay, so if you do the T1, T2, T3, and find the differences there, you find the same difference, which is D is equal to 1. Okay, so when you do that, it means it's an arithmetic series. Okay, this is an arithmetic series, and our A in this case is 1, and our D, we said our D is 1 also. Okay, then the number of terms, which is our Tn, our N. Okay, our number of terms in this case, I can simply say is equal to 1000. Okay, you may ask me, why am I saying 1000? Okay, I'm saying 1000 because I can use an equation of an arithmetic series which says Tn is equals to A plus N minus 1 by D. To find the N there, I want to find the N. Now, substituting the information that we have, I've got Tn, I'm saying it's 1000. That's the number of terms that we are given. I want to find N there. 1000 is equal to, our A is 1 plus our N, we don't know, so it's N minus 1 by our D, which is 1, this one. So when I move this one, this side, I'll have 999 is equal to N minus 1. And this one can move this side, and I'll have a 1000. Then this becomes N. So in other words, we are saying number of terms is 1000. That's why I was also saying the number of terms at first there is simply 1000. Okay. So now, because we know the last term of our series, we can use the formula Sn is equal to Na plus L over 2. The one, we know the last term, okay, is 1000. So we can now substitute for this one. Substituting, we are saying summation of 1000 terms is equal to our N, we said it's 1000, by our A. Our A is 1 plus last term 1000 over 2. And if you do the division there, you should get over 2 there. You should get summation of 1000 terms as 500,500. Okay, that's the solution there. Okay, let's have another example. Okay, here I've got sum of all multiples of 3. So when we have all multiples of 3, it means the series becomes 3 plus 6 plus 9 plus 12 plus ... I can also have, since we are talking between 400 there, I can have the last term here as 399, because 3 can go into this one. Okay, so this is the last term there. Okay, that's why I'm having this one. Now, first term is, this is my first term, that's my A there. My D, do I have a common difference? If I say T2 minus T1, what do I get? I've got 6 minus 3, I'll get a 3. If I say T3 minus T2, what do I get? I will get T3 minus T2 then. This is T3 minus T2. I'll get 9 minus 6, I'll get 3. So here we've got a common difference. So this is our D there. Okay. Now we want to know N, our N. So number of terms in this one, we can say our Tn is equal to nth term. I'm saying Tn is the nth term, is equal to 399. Okay. That's 399. So you can find now the number of terms that we have in this series using Tn is equals to A plus N minus 1 by D. Okay. Our nth term is 399 is equal to A is 3 plus N minus 1. Our common difference, we said, is 3 again. Okay. So simplifying this, I'll have this one going this side. I'll have 399 minus 3. I'll have 396 is equals to N minus 1 by 3 there. Okay. Then I can now divide both sides. I can divide both sides by 3. by 3. Here 2 cancel, and on this other side I'll have 3 1 3 1 3 2 here. Okay, so at the end of the day I have got 1 3 2 is equal to n minus 1. Okay, simplifying again, this goes this side, it becomes an addition, so I'll have 1 3 2 plus 1 is equals to n. Therefore our n terms, number of terms, is 133. Okay, so we have got 133 terms in this case. Okay, having 133, we can now go to our equation. Summation of n terms is equals to n over 2. We know the last term, so we've got a plus l. Last term we know, so we can substitute. Our s of 133 terms is equal to 133 over 2 by a3 plus last term 399. Okay, and if we have that one, we can simplify this and have our final answer of summation of 133 terms as 26733. That's what we do when we are looking at such a question. Now let's move on to another question. Here I've got sum of this. We are given the expression for sum of n terms there, and we want to find the sum of the first 8 terms, sum of the second 7 terms, and also the 8th term. So we are going to use this equation for all the questions. Okay, so let's do the first question. The first question, we will simply write our Sn is equals to 3n squared plus 2n plus 1. Our n in this case is 8. So we are going to substitute. For every n, we are putting 8. For every n, we are putting the 8 that we had on the question there. 8 terms. Okay, so putting our 8 then, we will have summation of 8 terms is equal to 3 by 8 squared plus 2 by 8 plus 1. Okay, simplifying this, you can find summation of 8 terms to be 209. Okay, let's do for the next ones, s of 7. For s of 7, summation of 7 terms, our formula is Sn is equals to 3n squared plus 2n plus 1. In this case, our n is 7, so we are substituting for every n there with our 7. Substituting, I'll have at the end of the day, S7 is equals to 3 by 7 squared plus 2 by 7 plus a 1. Simplifying that, you should get your S7, summation of 7 terms, as 162. Okay, so we go on to the last question. The last question is find the 8th term. Okay, using that formula there. The 8th term for this one, we are saying we have got S. Our formula is S. Let me write our formula. Sn is equals to 3n squared plus 2n plus a 1. Okay, and we want to find the nth term. There is this important formula that I'm going to give you, which says for us to find the nth term, we use this formula Sn minus Sn minus 1, which means that I will simply say for this nth term, I'll subtract it with an n minus 1. For example, if I say, in this case, I'll do the equation that we have here. We want to find n term number 8. I'll simply say S8 minus S8 minus 1. I'm putting 8 on all the ends there, meaning to say at the end of the day, our formula becomes T8 minus S8 minus S7. Okay, so that's what you get at the end of the day. Now, substituting the information that we had calculated earlier on, summation of 8, this was an equal sign here. Summation of 8 terms, we had our value as 209 minus summation of 7 terms is 162. Okay, so when we subtract those ones, we will get 47, meaning our term number 8 is equal to 47, like that. Okay, now let's go on. We have got what we call sigma notation. Remember, we have been talking about an S there, meaning it's summation or sum. Okay, now we have introduced this sign, which is called the sigma. Basically, it means we are adding. Okay, so when we are adding here, I can have an example whereby I can have a summation of k is equals to 0 to the nth term there, and we have inside here k. So I want to tell you what each of these mean. Okay, the value of k can be, we can have the k is equal to 0, meaning our first integer, our first number, our first integer for this one, our first integer for this one is 0. We are going to have a 0 here. Okay, then the last integer that we have, or the last term, we are going to increase up to n there. And we have got the formula, which is k. So basically, this is what we do. We have, and I can write this as, if I want to expand this summation sign, I can have 0 plus 1 plus 2 plus 3 plus up to n term, which is the last term that is being shown on this part here. This is the one. The 0 is the one that is starting here. That's basically what we have. Okay, now let's have something that is more realistic. Here I've got my last term as 5. I've got it as 5. The first one coming, the number of terms that I have, I've got 5. That's the n here. Then the first integer, we are starting at 0. Okay, and we still have the same formula k. Okay, so for me to get the number of terms, let's start with the number of terms. The number of terms for this one, we have got a formula. Number of terms is equal to top number minus bottom number, then we say plus 1. Okay, this doesn't come out well, so I'm saying top number minus bottom number plus 1. So let me try to show you. Top number is 5 minus bottom number is 0. Then we say plus 1. That's what I'm saying. The sum of terms here is simply that. Okay, I'm trying to show you. So at the end of the day, I'll have 5 minus 0. I've got 5 plus 1. So I'll have 6 terms here. So these are the number of terms that we have. Okay, so that's what we do. Then if we want to expand this one, if we want to expand it, we can expand it and have, we can have first term 0 plus 1 plus 2 plus 3 plus 4 plus 5. Okay, this is our summation. Okay, when we do, and we check the number of terms that we have got number of terms 0, 1, 2, 3, 4, 5, and the end there, the number of terms there are 6. 1, 2, 3, 4, 5, 6. This is the last term, which is this one here, 5. Okay, and if we want to sum these 6 terms, we can add 0 plus 1 plus 2 plus 3 plus 5, 4 plus 5, we get 15. So the answer for this one, we end up having as 15 is equals to 15. We are coming from this point here. Okay, let's have another example, a more realistic example. Okay, so this question here is saying determine the value of the following. So what you do first for this one is to expand. Okay, so you can expand. Okay, before we expand, let's find the number of terms. We said top number 4 minus bottom number plus 1. So number of terms here, I've got 4 terms. So I'll have 4 terms. Let's expand. First term, I've got 2 plus 2 plus a 2 plus a 2. So here I'm going like from 1 to 4. So I've got these 4 like this. Okay, and if I sum up these ones, I'll get 2 plus 2 plus 2 plus 2, I'll get an 8. Okay, so that's how you'll be doing this. Okay, let's have another question. Okay, this is repeating. Let's have another one. Okay, this one now, what we do for this one, we first of all write an expansion and also find the number of terms that we have. Number of terms is 13 minus 1 plus 1. So I've got n terms as 13 there. Okay, so that's my n there. Okay, now, so there's a difference between number of terms and also the nth term. Number of terms and the nth term. Okay, there is a difference there. Now we have to expand this. First of all, I'm going to put my r as 1. Here I would be changing 1. So, and expanding. So the first term I'll have 3 plus 1 minus 1 by 3 over 2. What do I get? For this first one, this one, I will get here a 0. So when this one is a 0, at the end of the day, they cancel off and have a 3. So the first term is 3. We do the same for the second one. Let's do for the second one. The second one, I'll have 3 plus a 2 minus 1 and 3 over 2. What do I get at the end of the day? This one becomes a 1. This is a 1. So I've got 3 plus 3 over 2. I will get 9 over 2. Okay, so we do the same for the second one. The second one, I've got 3 plus 3 over 3 minus 1 by 3 over 2 here. This becomes a 2, and when we have a 2, this one and this one will cancel, and I'll have my term number 3 as a 6. Let's go on the other one. If I do the other one, I will get the other one. I will have a 3 plus a 4 minus 1 and multiplying by 3 over 2 here. Here I'll get a 3. 3 over 3 by 3, I'll have 9 over 2. So I've got, at the end of the day, I've got here 3 plus 9 over 2. I'll get 15 over 2. Okay. So you do the same up until you have the term which is 13 here. When we do up to the 13th term there, you will get a value. Let's see for the 13th term. For the 13th term, I'll have 3 plus 13 minus 1 by 3 over 2. So here I'll have 12. 12 can be divided by 2. 2 here, 2, 6. 6 by 3. So at the end of the day, I'll have 21 here. So writing my sequence now becomes 3 plus 9 over 2. Then I've got plus 6 plus 6 plus 15 over 2 plus dot dot up to 21. Okay, so that's how we have expanded our first sequence. Now this is our A. This is our A. Okay, and our N, we said, is 13. Number of terms we've calculated. Now let's sum these terms. This is 6. Summing these ones, we know the last term. Okay, and our series is geometrical. If it's geometrical, we are going to use Sn is equals to Na plus L over 2. Okay, when we do that, let's substitute what we have. We've got S of 13 is equal to 13. 3 plus 21 over 2. If you simplify that, you should get 156. Okay, that's how you simplify. Let's have another last example before we end. It's we end the lesson. So for this one again, we do the same. We expand. Okay, number of terms for this one. Okay, this one is asking us to find the n value there. Okay, that's fine. So we cannot find our top minus bottom plus 1, that one. Let's see. Now we can expand this one. Let's expand. We are starting from k is equals to 1 up to n. So we can go as far as we want. And we are told the sum is equal to that one. Okay, so sum of n terms is going to be equal to this one. Okay, now expanding, the first term that I'll have, is 3 by 2 to the power of 1 minus 1. I'll get a 3 there. 2 to the power of 0, I'll get a 3. Then if I go on and do for 2, 3 to the power of 2, 3 by 2 to the power of 2 minus 1 here, I'll get a 6. Okay, let's do for the next one. I've got 3 by 2 to the power of 3 minus 1. So it's now 2 to the power of 2. 4 by 3, I'll get a 12 here. Okay, then let's do on. So you can do on and on and on. So basically what it means here, the nth term for this one, what it means, the nth term, dot, 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 the nth term is gonna be 3 by 2 to the power of n minus 1. That's the nth term. So the series that we have after this is equal to, the series that we can generate is equals to 3 plus 6 plus 12 plus dot dot 3 by 2 to the power of n minus 1, like this. This is our series. And we can see it's a geometrical, because I can say T2 here, T2 minus 1 divided by T1, I'll get a 3. T3 over T2, I'll also get a 3. So we have got a common difference there, which is 3. Okay, our R, sorry, we have got a common ratio there, which is 3. We've got a common difference, which is 3. Okay, having our common ratio is our common ratio is 2. It's not 3. Sorry for that. Let's correct that one. Our common ratio is 2, because if we say 6 divided by 2 by 3, we'll get a 2. My mistake there. So here is 2, 2, 2, 2. Okay, and our A is 3. Okay, now let's do our sum. We know our R is now greater than 1. So sum of these ones is gonna be, it's going to come as summation of n terms is equals to A R to the power of n minus 1 over R minus 1. Substituting, summation of n terms we said is 381, is equals to 3 to the power of times 2 to the power of n minus 1 over 2 minus 1, like that. Okay, so when I have something like this, I can divide both sides by 3. Let's divide by 3. So I'm going to multiply by 1 over 3 by 1 over 3 here. Okay, this one, it cancels. This one I'll have 127 here. So I'll now have 127. 127 is equal to 2 to the power of n minus 1 over 1. Okay, so this is 1 here. This one is 2 minus 1, I get a 1, so I'll just leave it like that. Okay, so we now have 127 minus 127 is equal to 2 to the power of n minus 1. Okay, and when we have something like this, we can okay, minus 1 there. So we can change the minus 1, this one, and come this side. So at the end of the day, I'll have 127 plus 1 is equals to 2 to the power of n. And I'll have 128. This becomes 128. 128 is equals to 2 to the power of n. And I can write 128 in the terms of power of 2. And this is 2 to the power of 7 is equals to 2 to the power of n. Therefore, my n term is equal to 7. Okay, so n is equals to 7. Basically, that's how we find the nth term there. Okay, guys, thank you so much. Let's meet in the following lesson. Please share our videos with your colleagues and also remember to subscribe. Okay, bye bye.